Um, one second. All right. So, thank you everyone for joining us today. I'm super excited to be hosting this panel on failing at AI. But before we begin, let me introduce the people on the panel today. Dr. Veronika Cheplygina, she received her PhD from the Delft University of Technology in 2015. After a postdoc at the Erasmus Medical Center in 2017, she started as a tenure track assistant professor at Eindhoven University of Technology. She will soon get to do her work at the IT University of Copenhagen, where she's starting her position as a tenured associate professor in 2021. Next to research and teaching, Veronica blogs about academic life on her blog and gives talks and workshops on failure and related topics. Next, we have Jaan Altosaar. He's a postdoctoral research scientist at Columbia University Irving Medical Center, focused on machine learning and healthcare. So his research focuses on machine learning methodology, such as variational inference methods or recommender systems, in service of addressing issues in mental health, health disparity, and women's health. He completed his PhD in physics at Princeton. He has interned at Google Brain and DeepMind and earned his BSc in mathematics and physics from McGill. Akash Srivastava is a research scientist at the new MIT IBM lab in Cambridge, Massachusetts, where he works on building machines with childlike common sense and intuitive physics using probabilistic modeling and Bayesian inference. Before this, he was a PhD student in the Informatics Forum at the University of Edinburgh, where he worked with Dr. Charles Sutton and Dr. Michael U. Gutman on variational inference for generative models using deep learning. So, what we're going to talk about today involves two parts. One of the parts is going to be recorded as we're going on right now, but we also saved a section based on Veronica's suggestion for just having an informal conversation where you can share things you might not want to actually publish freely, and like get the bottom line being give the students a better picture of what goes on the ground in machine learning and AI. So let's get started with a round of questions for all of you. And this is going to be a free for all. I'm going to present questions and you can take it, answer it, or pass. Pass is a very relevant option if the question is very hard hitting, because there will be those. So let's get started with a very simple question about failing at AI. Oh, and I'm going to be giving out, so the structure of this is going to be, there are points for the funniest fails, and the winner will get the most, the one with the most points at the end of this will be the winner, because life is a race and failing is common, so get used to it. So let's get started with the first question for the panelists today. Can you tell us about a time when you were really excited about a project but it panned out really poorly instead, and what did you do about it?
This sounds like practically every single project. I don't know the others, but I get really excited about everything, pretty much. And then a couple of weeks later, I realized, half of my derivations are not right. And then that's when the research starts. So I guess I'll say over time, I just learned that is how it's going to be. Initial enthusiasm is just what keeps you going after, a couple of chats with people who know more than you. You realize the flaws, and then you will spend the next half a year fixing it. And that's when you write a paper.
Okay, 100 points for Akash. Who's going next?
Yeah, I think mine would be not a specific project, but more that I tend to get excited about more things that I can take on, and in the end, most of them don't get done, even if they have potential. And I've sort of been trying to work on that over the years. But yeah, that's my fail. Taking too many things on and not finishing them.
75 points. Fair effort.
I was thinking about this just now, and maybe my biggest failure is yet to come, because it's what I'm currently planning on doing or wanting to do in the future. And I think that's the curse of being in science because our ambition is large. And so right now I'm thinking about projects in human to human interaction and thinking of ways to change how people communicate or give them more tools with the help of machine learning. And to me, it's such a grandiose goal is almost destined for failure. And so my challenge is how do I break it down into small successes? So I'd say what I'm doing now and what I plan to do.
120 points for that. Jan wins this round. Next question for all our panelists. How is the field of AI like or unlike the way it is depicted in popular media? For instance, how has it grown and like what are some of the factors limiting that growth? Yeah, go ahead. Feel free to unmute and talk.
I think you don't see in the media the sort of toiling away to getting something to work until it works and has good results. So we have this kind of publication bias of only showing things that worked, and those are the ones that get reported. But you don't see like all the hyperparameter optimization and all kind of the know-how that went into it. And I think that's quite harmful to the field. It creates a really unrealistic picture of how it works.
Bonus for
Just to follow up on Veronica's point, I think part of the hyperparameter optimization is just electricity and power. And if I think of, say, the recent successes, such as GPT-3 from OpenAI, which won a best paper at NeurIPS, then the cost of doing machine learning is itself a limiting factor because it can run into hundreds of thousands or millions of dollars per machine learning paper. And so I think that's one of the biggest factors, given that it's hard to see the financial returns on an investment in AI in an industry setting in a short term.
I've also heard of the term called grad student descent. Is you just put a grad student to optimize a specific problem. And the more, of course, positive results and the more funding you have, the more you can afford to do that. And
yeah, this question really sort of makes me think of those memes. You know, how my friends perceive what I do and what I actually do. Because half of the time it's like the other two panelists mentioned, it's a lot of hard work hidden behind. The only thing we show are the successes. And just building on Jan's point about like the compute requirements, I think that's something as a PhD student and then even now in postdocs at most universities, it's something you get faced with, that there are certain type of projects depending on where you are and you know what sort of resources are available, you can't even undertake. And that's sort of, I guess, you know, for me, it really underpins a lot of what I'm doing now. And then also the biggest difference when it comes to how it's perceived in the media.
So 1,000 points for the grad student descent, 500 points for the meme references. So we clearly know who's leading now. The next question we have is an interesting one. So you raised this point about grad students, right? So would you say a master's is worth getting for students, since we have a crowd of undergrads right now who will potentially face this decision in their lives, right? Whether a job versus a PhD versus a master's or whatever they do next. Is a master's worth it to go into AI research? And they've already provided these arguments for it. So the arguments for it include you get to specialize, and it takes usually 1 or 1.5 extra year in university. The arguments against it are that experience matters more and money. So take it away.
Yeah, so I mean, I can say that my experience with this is probably very different from most people who are attending in the US because of the different structure. So where I am, it's very common to do the bachelor's and master's together, and then in very few cases, a PhD. So in that sense, I think it's definitely worth it. I know many students who graduate from their master's who go on to, like, let's say, a kind of data scientist, research engineer position, like at Philips, for example, or you know some other kind of company. Also, PhDs here are not studentships, so you don't pay tuition and you get a salary. It's less than an industry salary, but it's not. I think the trade-off is quite different here.
Yeah, I think my experience was also pretty much like that over Veronica. So in the UK, most of the time, it's a sort of fairly rare to get a PhD or get into a PhD program right after your undergrad. And the only thing I would like to add is that it sort of also depends on how what was the focus area of your undergrad and how many if you happen to do a research internship or some research experience. Which in which case, jumping that master's is sort of somewhat it makes sense, because one key difference about the UK and the US PhDs is that there is no taught component as such in the UK PhD. So you don't attend any classes, and again, you have a stipend, so it's considered, like Veronica says, considered sort of a job. You can attend classes, but that's, given that it's only 3 years, you don't want to waste, well, I shouldn't say waste. You don't want to take time away from research, because you only have 3 years and there's no time to learn as much. So it just becomes a sort of a tighter call at that point.
Yeah, so it's similar here, and I mean, you can attend classes, but this is also why a master's it's not officially a prerequisite, but it's mostly expected that you have it once you apply for a PhD, because the students from around here will have it.
I would say it depends on career goals as well. If your goal is stability, then definitely not a PhD. Or if your goal is money, then it's definitely not a PhD. And if you look at, say, the AI pay grades website, you can see all these big numbers, but I think the AI hiring boom for PhDs is bursting. At least there's some industry labs that have shut down or been sold to competitors. And so I think the boom that we saw is going more into hiring people with master's degrees instead of PhDs, especially as the tool chain to make well-performing machine learning solutions in industry becomes more accessible. And so if your goal is to do research, then I would say get a PhD, but with the expectations that you'll make less money in the long term, and that there's this trade-off in terms of stability, that if you know exactly what you want to do and you're passionate about research, then it might be worth spending 5 or 6 years in grad school, but it really depends heavily on the goals, and you should not do it for money because there's much quicker paths. And in some cases, your company might even pay for you to do your master's.
I think for the record, I have to state that when I started my PhD, machine learning was not popular at all. It was actually a more stable job than like a short contract in industry. And really, I had no goal for like 5 years ahead. It just seemed like, well, this is a nice group to work in, and I get to do something that I studied for. So why not? Of course, these were different times, but I had very different kind of considerations in terms of stability and goals, I would say.
I guess I was just reading Hacker News and people were discussing deep learning and AI, and it seemed interesting.
3,000 points around the table for all these nice contributions. Bonus to Veronica for speaking twice. Good job, guys. Okay, so the next question we have is, what is the most contrarian piece of advice you can give to college students interested in breaking into ML and AI? Oh, there's a raised hand, so we'll go with Sabrina next. Contrarian piece of advice.
Is sending cold emails contrarian?
So we discussed cold
I think it's contrarian in terms of behavior. The number of people that I tell to give suggestions to send cold emails who then do it is very small. So in sense of behavior, then it's contrarian, but in the sense of general career advice, then it's not contrarian. It's a very normal piece of advice.
I'll give 30 seconds more for another piece of contrarian advice, or Jan wins this round.
Don't overthink it. Fields will come and go.
What will come and go?
Fields and topics will come and go.
This is a great point. I will bring this up again. Okay, Sabrina, take your question away. Take it away.
Hi, can you hear me?
Yes, we can.
Okay, thank you. So you were talking about the difference between a PhD and a master's, saying that the master's is, you said that PhD is not very good for the money and the master's, so I suppose master is better. So what is there are many types of masters, and there are the MOOC masters, the online things, and the in-person types of programs. So does the industry consider online learning with the same weight as a master's in a big university with a name, or not?
That's a good question, Sabrina. I would think about it from your perspective instead of the potential employer's perspective. And just, if I'm thinking about, is it worth it to do a master's degree, I'm thinking of what am I getting out of it? And in terms of where am I going to get a job, it's usually through somebody I know. And if it's in person rather than online, I just, like, my prior is that you can make closer connections, friendships, learn a lot more. It's easier to reach out for help for assignments, collaborate. And for me, at least, that's been the bulk of the learning in grad school, is in-person interactions. And because of that, I have a very strong prior if I see on somebody's resume that they did an online master's. If they did an online master's, I'll want to see a lot of evidence that they've done that type of work, like collaborated with people, worked hard to make those types of strong and weak ties, even through an online program. So I think it's possible, but I would strongly suggest in person if at all possible. But I know the pandemic has upended things, so that may change the calculus.
And also, I don't know if you're able to say right now, but is there a list of the universities that are better, or the programs that are considered better, that the companies usually go for those programs?
Again, I would think of it like, where will I get the best education? Because that will help guide the right decision. And yes, I think Pooh's right that NYU data science is the very best.
Okay, thank you.
All right, so the question I have next is more for the field of medicine. So we have a question from one of the students. Is the medical field ready and eager for AI, or are clinicians generally resistant to new technologies? For example, do you see ML-based diagnostic systems becoming the norm in everyday healthcare?
That's a good question. And one way I think about that is, in which part of the whole healthcare system can machine learning play a role? And I think there's several ways to think about that. One is in the actual clinical profession, like at the point of diagnosis or point of care. The other is on the insurance side. And I think machine learning is already being used in all stages of that, whether it's, say, trying to surface relevant information to a doctor, say like UpToDate.com, which is a website for clinical guidelines that doctors consult for medical advice, that might use machine learning behind the scenes to surface information to your doctor the next time you go visit. Or on the insurance side, the insurance company might pay out or not pay out according to their analysis of your risk as a patient. So I think the healthcare field is already using a lot of AI and machine learning, and it's only going to get bigger in the future. So it's an exciting area to be in.
Yeah, I think I definitely agree with you on that one. Just to add a little bit of more of the speculation here. According to some of the studies, most public healthcare systems like the NHS will run out of the money in like 10, is it 10 year or 5 year time? As a time frame in which in the current rate, they won't be able to provide the same level of service that they do right now. And one of the most promising ways in which most technology companies are sort of trying to solve that problem is through machine learning. So there's a lot of reason for it to succeed. Where that will happen, that's sort of where the speculation comes into. But certainly, it seems like people are trying hard to make that happen.
So maybe what I'd like to add, I think there's a lot of potential for many sorts of applications. I think these kind of like decision-making things is not what people are really after. That seems much more hype to me than what's happening in hospitals. What many like radiologists I work with, what they would like to have are much simpler tasks solved, which are not directly related to them treating the patient. So it's a lot of like pre-processing the scans, for example, aligning different scans in points in time so they can compare like if a certain tumor has grown or not, actually outlining different organs so they can measure the volume. So these kind of much simpler tasks, which are they're very happy to outsource. And I think that's what the focus of many medical imaging conferences is now, for example.
Those are great points. Points are on the table. Points don't matter anymore. So the next question we have is more about, you mentioned grad student dissent before, and I want to get back to like the point about students that we have on call, and we have our panelists joining us, Siddharth Srivastava from India. Thanks a lot for making it to the call, even though it's really late in the night and I messed up the calendar invite.
Hi everyone.
So
sorry for being late.
In the interest of time, I'm going to continue, but I'd like to say one or two lines about Siddharth first. He works as a principal technical officer at Center for Development and Advanced Computing in Noida, India. He's leading AI initiatives in health informatics, and the systems designed by him are being used by millions of users even today. So welcome to the panel. The others are already ahead of you in points, and we've closed the board, so they already won. I'm really sorry you have failed at winning. But you really now had a chance. Okay, so getting back to the line of questioning, grad student dissent. So all of these undergrads here, they want to get into AI at some point or in some way, right? The reason they're attending the school is to learn more about AI. Now, there was a discussion on Twitter by a researcher, an independent researcher who tried to publish a paper at a really popular conference, and he actually succeeded. And even after that, when he wanted to try and get into a good research engineer position, which is not that much of like, it's not like you're saying, I want to become a CEO of a company, it's a position at a company. He wasn't able to, and for a variety of reasons, but mainly that every position has some expectations that seemingly were too high for him to make the bar. And that raises this broader point of grad school and the expectations that grad schools have for students coming in with, they already have so many candidates with experience that it automatically becomes a high bar for students who don't have the opportunities to get that experience. So what can we do to help these students make the cut?
I'll come back to my contrarian advice, which is to send cold emails. Because like say, I was able to mentor a high school student during the pandemic, and they live in Missouri, and they sent me an email in March, and I helped them publish their first paper at a workshop at a machine learning conference, and then that helped them get into college for machine learning, which is what they want to study. And so I think the more emails you send that show that you've done somewhat of a good job, say matching your interests to your potential mentors, then the more of a chance you can find a good match in terms of your interests and theirs and get that experience. That might seem like a very high bar right now, but if you can demonstrate to somebody that's doing something similar to what you want to do with skills that you might want to learn, then just send more emails.
I would say don't send more emails, send less emails, but good ones, and make them specific. I get quite a lot of emails, which I suspect are sent to thousands and thousands of, I read your papers and you are working in deep learning, which is also the field I'm working in. So tell me about more opportunities.
I agree with
Sorry,
Veronica.
I
Like, say
cannot.
this one student, then it was clear that he had read my papers, he had read my work, and it was a very personalized email. And so it does take effort, but say it takes minimal effort compared to other things that you might do to get yourself to meet the bar for, say, grad school.
Yeah,
Exactly.
I'll just add to Jan's point that maybe also try to reaching out to people in industry as well, because there are a lot of people who are very, very willing to help out. Professors generally are very busy and they get a lot more emails than I'll say junior industrial researchers. So that's another sort of network that you want to tap into. With regards to cold emails, or join Twitter and message a bunch of them. They are very active there.
So
And I think something else that's coming to mind is if you're independent and you are curious about something, there's nothing wrong with going to Library Genesis, getting a textbook on statistics or machine learning, and then self-studying and putting some projects up on GitHub or having a website with a portfolio. Because that's all something that both companies and grad schools look for, of just evidence or work samples that you know how to learn on your own, whether that's from a textbook or an online course like fast.ai, and you can implement the solutions, your code quality is high, and you have communication skills, you can write well. And so having an online portfolio, website, blog, or GitHub, those are all things that anyone around the world can do. And especially with resources like Library Genesis and fast.ai, the bar is coming down in terms of access to those resources.
Yeah, very much agree
Sorry,
with this.
go ahead, sorry, go ahead.
go ahead, please.
Evidence of projects is great, and it doesn't even need to be something that's resource intensive, but just showing that you've dove into some field and did some kind of project in it. It could be even like the classical kind of pattern recognition, which you can do in 20 seconds on any modern computer. I think that's already shows the kind of mindset you need to have as a researcher. So it doesn't need to be resource intensive, at least for me. And maybe to come back to the original question, don't just look at the ranking of universities. There's lots of places, I think, which are not so famous and which have good people you might want to work with.
Yeah, right. I would like to add 2 points to that. So, like everyone said, that send hundreds of email or send quality emails. So, since my undergrad days, I've been involved in a lot of placement committees here at different colleges in India as well. So, I would even in some abroad ones. So, I would really appreciate if people are sending hundreds of emails which are personalized to the work to which you are, to the person who you are sending it to. So better read their work first, understand their work, maybe try to find some problems in their work or some interesting points that you like in their work, mention those, and then send an email. It is a very high chance of getting replied immediately, even if the professor is busy. So you might eventually land up with some PhD student or postdoc, or even in the industry, we people certainly like if someone sends us a good email. Second is the other part of the question of Swapnil was that how should they plan to go ahead becoming CEO or rising in the organization based on whatever skills they have, or how to get those skills. So in industry specifically, I would advise don't prevent yourself from or limit yourself doing only the fancy work, that designing deep learning algorithms, and you'll just write the code on for those deep learning algorithms. You have to do a lot of ugly work behind any algorithm to make it work. You have to clean the data. You have to sometimes just go back and redo all the data. If you're working on a novel problem, you may have to collect that data itself and work with the researchers or the developers to make sure that things are done as per your requirement. And once all that is done, the last 10% of the work is the fancy work, which you really enjoy and where your 90% of the effort goes. So do not fear from diving into things which are not actually directly look suitable to you for that particular problem.
That's a great point. And there's a question that Veronica already answered, but I want to pose it to the rest. Has there ever been a time that you got a memorably unexpected result with AI, not in a good way, but in the kind where the machine learned incorrectly? You can also repeat your answer for the rest if you like.
I may add one. I would like to just add one during the COVID time itself. Like I work in the health informatics sector, and our work is mostly to design systems which are used directly by doctors, practitioners, and entire medical staff. And then whatever is there is being used by the patients. So we were working on some use cases for during the COVID time for recommending some sort of disease that based on specific inputs, you are supposed to get disease recommendations.
When you say recommend, you mean prediction?
So yeah, prediction. So not based on exactly clinical parameters. When it comes to practical usage, there are a lot of limitations when you apply AI to health informatics and when it is actually being used at hospitals. So it is being used by doctors who are working in the outpatient department, who are directly interacting with the patient as well as entering things into the system. So you have to show some recommendations there. So we were in our proof of concept stage, and we did this all standard stuff, data cleaning and everything, cleaning out all the what we call nonsense data. And we built a state-of-the-art recommendation system with 99% accuracy. And we were trying to demonstrate it. And the doctor asked us, just enter common cold and let me see what happens. And the problem is that usually at super specialty hospitals, the hospitals we work are amongst the busiest in India, people with symptom of common cold rarely come. Or even if they come, they are say hundreds or 200 patients out of 10,000 patients that are visiting daily. So during data cleaning and just tweaking out imbalanced and everything, it just got filtered out. And there was nothing from the system. that whether common cold, what will common cold do? Or what are the probable diagnoses which people with common cold face? And so it was an eye-opener that when you clean data, you organize everything, you should not actually look away. And it was not our system. It was with systems from a lot of big names as well. So they all of us were given the data and we were supposed to do something with that data. So it was a very quick POC, which we had to do in 15, 20 days. But still, during COVID times, nobody thought of whether common cold is a symptom, because a lot of COVID patients were there, but the load was, say, they gave us data of about 60,000 patients. At that particular time, COVID had just begun and only 500 or 600 patients were there. And all of them ironically had this common cold or fever as their symptoms out of 80% or 90% of them. So that was one thing where we were kind of embarrassed as well, but learned a few lessons as well.
So I have a very similar data pre-processing related lesson that I learned very recently. We were working on this sort of contrastive learning type problem, actually more to do with the texture and the shape bias in image classification task. And we had this pretty nice solution where we essentially tried to create a mixture of two ResNets one was intentionally biased towards the texture, and the other one was intentionally biased towards the shape. And then sort of was trained in that particular manner, and we were seeing these test accuracy numbers in like 80, and it went to 85, 89. At that point, we were seeing numbers from ResNet 50 that were better than EfficientNet. And so, this is one of those times when, like, okay, we have dawned upon something which is going to be, the talk on Twitter. So it's just as a matter of fact, we were like, okay, let's go and just double check everything before we release it. This came very close to being released, and then we realized that during the pre-processing, when we were trying to create the pair data set, somehow there was an end of file error, and somehow the pre-processing package was deleting one file in one of the legs, right? So there was actually a sort of a mismatch. It wasn't the same image texture in the texture component and the shape component the same. It was the texture of one image and the shape of the another image in the same class, which, as you can now understand, is a completely different problem. So we did learn a great deal that there's something called the two sample classification task, which probably doesn't exist, but and for that, ResNet 50 is great. But it's definitely not solving the shape and texture bias. Although our method did improve the ResNet accuracy by 2% point, which is not as remarkable as 13. Yeah.
All right, so I'm going to stop recording after this, and I have one or two more questions before we close out the panel. So I'd like to thank everyone for being a part of this recording, and now we go offline to the interesting stuff.